An introduction to limits, graphical limits. We're going to start with some notation. So when you're doing limits, you might see this following the notation, which looks like this. It is the limit of f of x as x approaches a. What we mean by this is when x is getting really close to a specific value, what is y getting really close to? We're not talking about what happens when we get to x equals a, but just when we get really close to x equals a. So in the graphs that we're doing, where we have two dimensions, we have an input and an output, we can approach x from two sides. We can approach x from the less than or negative side, and the notation would look like this. X approaches a from the less than or negative side of f of x. So we're really looking for a y value. Or we could approach from the greater than or positive side, and the notation will look like this. The limit as x goes to a from the positive or greater than side of f of x. Let's look at a theorem. When you're first starting calculus, sometimes they call this a definition, but this is a theorem, which says the following. The limit as x approaches a of my function will exist and equals a value, we'll call it L, if and only if, I'll write it like this, if and only if the limit from the less than side equals the limit from the greater than side, where they both equal that value L. So the idea is when we get really close to an x value from both sides, are we getting close to the same y value from both sides? Let's look at a picture to help us understand it a little bit better. So right here we have a graph of f of x that has some discontinuities. We'll talk about what that means formally later on, but you've probably seen that concept before calculus. And we're going to find some various limits and function values at 4 different x values. Let's start as x is approaching negative 3. So right here is x equals negative 3. So as we're getting really close to x equals negative 3 from the less than side, look how y, or the function, is getting very close to 1. Now does f equal 1 at x equals negative 3? And the answer is no, but that's irrelevant, because a limit is not what happens when we get there. It's what happens when we get really close. Now let's take a look as x is going towards negative 3 from the greater than side. What is y getting really close to? Well, it's also getting really close to 1. Let's take a peek back at our limit theorem, which says the following. The actual limit, notice the actual limit up here, which does not have a superscript, is implying that you're looking at this limit from both sides. And this limit will exist if and only if the left and right sided limits equal the same thing. This is the key to understanding a whole bunch of things we're going to do with limits going forward. Back to the graph over here. The limit from the less than or left side, or the negative side, we say all those things, equals the same value from the greater than or positive side or from the right. So the function has a limit of 1 as x gets close to negative 3. Now, if I'm asking for f of or f at negative 3, I want to know what the y value is when x gets to negative 3. But notice that in our picture here, I don't define the function there. So we say that the function at negative 3 is undefined. Let's do the same thing at 3 more x values. We'll start with the limit as x goes to 0 from the less than side. So as x is getting close to 0 from the less than side, notice that y is getting really close to 3. As x is getting close to 0 from the greater than side, y is getting close to 3. The fact that we get to 3 doesn't matter with the limit. But since these two limits, the less than and greater than side, have the same limit, the actual limit is that value is 3. And if I want to find f of 0, well, that of course is also 3. How about as x goes to 2 from the negative side? Well, as x is getting close to 2 from the less than or negative side, y is getting really close to 0. As x is getting close to 2 from the greater than side, y is getting really close to negative 2. Now, y doesn't equal negative 2, but again, a limit is when we get close. But notice that these two values are not the same, which means that the limit does not exist, which I'll write as d and e. How about f of 2? Is the function defined at x equals negative 2? Well, yeah, it is. It equals 0. One final limit. Let's look at x going towards 4 from the less than side. Notice that y is getting really close to negative 4. It doesn't reach it, but again, that doesn't matter with the limit. As x is getting close to 4 from the greater than side, y is getting really close to negative 4. And since these two limits are the same, the actual limit is that value and does exist. But what about f of 4? F of 4 is right there. F of 4 equals 0. So the function at x equals 4 is 0. What does that have to do with the limit? Absolutely nothing. Because a limit is what's happening to the y value or function value when x is getting really close to some particular value from both sides.